Okay, in this video, we will look at a few other situations that arise when you are simplifying radicals. Let's say you're going to simplify the square root of 24. And here is the prime factorization you've done. And you have 2 times 2 times 2 times 3. So you actually have a cube. This is 2 cubed times 3. Well, when you are simplifying square roots, you don't want cubes. Cubes are good when you're doing cube roots, but we're doing square roots. So what's best to think of this is not 2 cubed, but think of this as 2 squared times an extra 2. 2 to the second times 2 to the first, because squares are what will simplify. So when you go to work this out, the square root of 24, we'll write it as 2 squared times the extra 2 times 3. And then we'll simplify the square root of 2 squared. You don't have to write the step where you write them separate once you work a few of these and you get the basic idea. This simplifies into a regular 2. All right, this is really the square root of 4, so that's why that's just the normal number 2. Now, this 2 times the 3, that's 6, and we're doing the square root of 6, which is not the number 6. Okay, all right, so the square root of 24 simplifies into 2 times the square root of 6. All right, here's another problem to illustrate something else. Let's say you have the square root of 300. Okay, so I did the prime factorization, and I have 3 times 2 times 2 times 5 times 5. It really doesn't matter what order that you write things in. Some people want everything in numeric order. It can be nice. If you put it in order, you have 2 squared times a 3 times 5 squared. Okay, so in this problem, you have more than 1 squared. So basically, the 2 squared and the 5 squared, those are what will simplify. And you could write them separately, right? And then the 3, that's stuck all by itself under the square root. Okay, now the square root of 2 squared is going to become a 2, and the square root of 5 squared is going to become a 5. Right? This is really the square root of 4. That's the square root of 25. The square root of 3 just stays like that. So you're going to end up with normal numbers of 2 times 5, so you're going to have 10 multiplied by the square root of 3. Okay, so at the very beginning, when you have this, I'm going to always want you to write the prime factorization. I'm going to want to see that step. But then at this point, you can say, all right, this is going to simplify and come out of the radical, and so is that one. So you could just write 2 times 5 outside the radical. Whatever's left underneath stays underneath, and then you can write 10 times the square root of 3. Right? So you don't have to do all the work breaking it apart unless you want to. All right, now, sometimes your radical will have a coefficient. So this is like 2 times the square root of 18. So it just means that you're going to simplify the square root of 18, and whatever you get, multiply it by the number 2. All right, so here's the prime factorization for 18. 2 times 3 times 3. So you can see we have a square. That's good. So this is going to be 2, and then 2 times 3 squared. Okay, so only the squares escape from underneath the square root. This is going to work out to just be a normal number 3. So you could, you have that 2, you could just bring that one out and write times 3. This 2 is left underneath there. That's not the number 2. This is the square root of 2. It's like 1.4 something. This one is the number 2. All right, so the whole numbers we can multiply together. 2 times 3, we'll have 6, and then times the square root of 2. So that's the simplified version of 2 times the square root of 18. So these are what we call exact values. Right? If you use a calculator, then you are